Hi everyone, welcome to Drawing Hub. So this is Computer Graphics and Image Processing Module 1 Part 8. So we are going to start line drawing algorithm, that is the second half of the first module. Now this is chapter 3, page number 93 of the textbook. A picture can be displayed in several ways. Assuming we have a raster display, a picture is completely specified by the set of intensities for the pixel positions in the display. First, we have to learn what is points and lines. Okay, points and lines. Point plotting is accomplished by converting a single coordinate position furnished by an application program into appropriate operations for the output device in use. Points and lines. Point plotting is accomplished by converting a single coordinate position furnished by an application program into appropriate operations for the output device in use. With a CRT monitor, for example, the electron beam is turned on to illuminate the screen phosphor at the selected location. How the electron beam is positioned depends on the display technology. A random scan, that is vector system, stores point plotting instructions in the display list. And coordinate values in these instructions are converted to deflection voltages that position the electron beam at the screen locations to be plotted during each refresh cycle. For a black and white raster system, on the other hand, a point is plotted by setting the bit value corresponding. We have already discussed about it in this previous videos. Corresponding to a specified screen positions within the frame buffer to 1. Then, as the electron beam sweeps across each horizontal scan line, it emits a burst of electrons. That is what we call floats a point whenever a value of 1 is encountered in the frame buffer. With an RGB system, the frame buffer is loaded with the color codes for the intensities that are to be displayed at the screen pixel positions. Line drawing is accomplished by calculating intermediate position. So first, it is about, this is just an introduction. You don't have to mark this is just an introduction. Now, line drawing, how do we do line drawing? That is what we have to look forward. Line drawing is accomplished by calculating intermediate positions along the line path between two specified endpoint positions. An output device is then directed to fill in these positions between the endpoints. For analog devices, such as a vector pen plotter or a random scan display, a straight line can be drawn smoothly from one endpoint to the other. Linearly varying horizontal and vertical deflection voltages are generated that are proportional to the required changes in the x and y directions to produce a smooth line. So, line drawing, the basic definition. It's not the definition, it's just an introduction here too. So, how do we get the line drawing? Line drawing is accomplished by how calculating the intermediate positions along the line path between two. We have two specified endpoint positions, and then we will calculate the line path between these two specified end positions. An output device is then directed to fill in these positions between the endpoints. Now, for analog devices such as a vector pen plotter or a random scan display, a straight line can be drawn smoothly from one endpoint to the other. Linearly varying horizontal and vertical deflection voltages are generated that are proportional to the required changes in x and y direction. Digital devices display a straight line segment by plotting discrete points between the two endpoints. Discrete coordinate positions along the line path are calculated from the equation of the line. For a faster raster video display, the line color intensity is then loaded into the frame buffer at the corresponding pixel coordinates. Now, reading from the frame buffer, the video controller then plots a screen pixel, and then we have the Jaggies. Now, this rounding of coordinate. This screen location are referenced with integer values, so plotted positions may only approximate actual line positions between two specified endpoints. Will not get the exact position, only approximate will be getting. And this will be later converted to pixel position. Now, for example, we are having 10.48 as x position and 20.51 for y. Now that we will round to 10 and 21. So this rounding of coordinate values to integers causes lines to be displayed with the stair-step appearance. We'll get it as Jaggies. We'll get in this form. The characteristic stair-step shape of raster lines is particularly noticeable on systems with low resolution. So those systems with low resolution, we find the Jaggies. And we can improve their appearance somewhat by displaying them on high resolution systems. So if we want to avoid these Jaggies, we have to display them on high resolution systems. More effective techniques for smoothing raster lines are based on adjusting pixel intensities along the line paths. So this is an example, the stair-step effect. See? Like this. So it will be in a stair-step manner, if you have noticed. Produced when a line is generated as a series of pixel positions. Now, for the raster graphics device level algorithms discussed in this chapter, object positions are specified directly in integer device coordinates. For the time being, we will assume that pixel positions are referenced according to scan line number and column number, that is pixel position across a scan line. This addressing scheme is also illustrated. Now, scan lines are numbered consecutively from 0, that is starting at the bottom of the screen. So from the bottom, if this is the screen, from the bottom of the screen, and pixel columns are numbered from 0. So if this is the axis, it starts from 0, left to right across each scan line. Now, to load a specified color into the frame buffer at a position corresponding to column X along scan line Y, we will assume we have available a low level procedure of the form. So this is an example. This is a scan line number. It starts from 0. Now, pixel position referenced by a scan line number and a column number. So this one, x-axis represent the pixel column number and y-axis represent the scan line number. Now we sometimes will also want to be able to retrieve the current frame buffer intensity setting for a specified location. We accomplish this with the lower level function. Use the get pixel x, y. So this is only about points and lines. We haven't entered to the algorithm part. Now the line drawing algorithm. The Cartesian slope intercept equation of a straight line, that is y is equal to mx plus b is the Cartesian slope intercept equation for a straight line. For a straight line is the equation y equal to mx plus b. Now here m represents the slope. M represents the slope of the line and b as the y-intercept. And b as the y-intercept. Given that two endpoints of a line segment are specified at position. So we are having two endpoints. We are having x1, y1 and x2, y2. Okay. Now we can determine values for the slope m and y-intercept b with the following calculation. So to find m is equal to delta y by delta x. So what is delta y? Change in y. So that is y2 minus y. Delta y is y2 minus y1. And delta x is x2 minus x1. So m is equal to y2 minus y1 by x2 minus x1. And b is equal to y1 minus mx1. We are just rearranging this equation. B is equal to, okay, B is there, Y is over there, so Y minus MX. Okay, now if it is for the first one, for the first point if it comes, then B is equal to Y1 minus MX1. Now algorithms for displaying straight lines are based on the line equation 3, that is on this equation. This equation, the Cartesian slope equation for the straight line you have to memorize at any case. This one, don't forget. And only with that we are calculating the rest of the equations. Now for any given x interval delta x along a line, we can compute the corresponding y interval delta y. So if x is given, then we can find delta y also. So delta y is equal, it is rearranging this equation, m equal to delta y by delta x. Rearranging it so that we get delta y. Then delta y is equal to, this will go this side. Delta x will go to the left hand side. So m delta x. That is how you get this equation. Now similarly, if we want to find delta x, we can obtain x interval delta x corresponding to a specified delta y. So if we want to find x, what do? This is over here, and then we bring the m to the denominator. Delta y, when it comes to the other side, when it comes to the left hand side, m will go to the denominator. So that is delta y by m is delta x. Now, this equation forms the basis of determining deflection voltages in analog devices. So for lines with slope magnitude, if we are having slope magnitude mod m lesser than 1, delta x can be set proportional to a small horizontal deflection voltage, and the corresponding vertical deflection is then set proportional to delta y, as we have calculated before. Now for lines whose slopes have magnitude, this is for m lesser than 1. Now if we are having m greater than 1, then delta y can be set proportional to a small vertical deflection voltage with the corresponding horizontal deflection voltage set proportional to delta x. Now for lines, now this is for either mod m is less than 1 or greater than 1. Now if it is equal to 1, then delta x equal to delta y, and the horizontal and vertical deflection voltages will be equal. So in each case, a smooth line with slope m is generated. So in all the three cases, a smooth line with the slope m will be generated between the specified points. Now on raster system, lines are plotted with pixels and steps sizes in the horizontal and vertical directions are constrained by pixel separation. That is, we must sample a line at discrete position and determine the nearest pixel at each line to the line at each sampled position. Okay. Now this is a figure of a straight line segment with 5 sampling positions along x-axis between x1 and x2. Okay, we are having this is x1, y1, this is x2, y2, and we are having the sampling positions. These are the various things, various points in the x-axis. Then we have about DDA algorithm. Before going to the DDA algorithm, we will look at the notes. Pixel and coordinate system. This is the coordinate position 6.26, 7.25 is represented by C. Okay, so now look over here. Okay, so this is this C position. The coordinate position of C is represented. So here we can see it is 6.26 x-axis and y is 7.25. Now B is also between 2, round off. Okay, A is somewhere in 0. That is how we do the coordinate system, how to mark it. Now pixel and coordinate system, again, screen is divided into coordinate system. Each pixel is considered as a unit area. So if this much is a pixel, then that is a unit area. Each pixel on the display surface has a finite size depending on the screen resolution. So depending on the screen resolution, each pixel will have the display surface. A pixel may not represent a single mathematical point. So pixel size, units may vary. Now point is a pixel. A pixel only approximates a point. We can only do the approximation, not the accurate one. Each pixel is accessed by a non-negative integer coordinate pair xy. Now the line, collection of points, that is collection of pixels, is what forms a line. Line is drawn by calculating the intermediate pixels along the line path. Along the intermediate line path, by calculating the intermediate pixels, the line is drawn. So choice of pixels is obvious for horizontal, vertical and vertical lines. So this is how we draw it. Okay. This is the chair step effect, the Jaggies. produced when a line is generated as a series of pixel position. Now, if we want to avoid this, we can make it by using a higher resolution system. Then line drawing algorithm. Line drawing is done by calculating intermediate positions along the line path between the two specified endpoints. How we draw a line is by calculating. We will have two and specified endpoint positions will be there, and we will be calculating the intermediate position. Now, what is the objective? To draw a line between two endpoints and provide a good approximation with minimal staircase effect. And then we have the Cartesian slope intercept equation for a straight line, which is y is equal to mx plus b. And this is the line path between n positions. We have x1, y1 and x2, y2, and we have this line. Now, the line drawing algorithm, basic first equation we have to write. B is equal to, see, we need to find b. B is the intercept, right? So, b is equal to y1 minus mx1. That is from this equation. We have rearranged to get b, and we are substituting it with first point, so y1 and x1. So b equal to y1 minus x1, and then m is delta y by delta x. So that is expanding it. We'll get y2 minus y1 by x2 minus x1. Shortening it, we'll get m equal to delta y by delta x. To get the value of delta x is equal to delta y by delta y by m. And to get delta y, it is m delta x. This is a straight line segment with 5 sampling positions along the x-axis between x1 and x2. Then DDA will discuss in the next video. Until then, bye-bye.